Okay, so here we are with our next little project in the making. What we have on the right hand side is a partly made gtd1752vkr, and on the left hand side we have the standard turbo for the Insignia. So a couple of things that are obviously different about these turbos is the GTD series has a ball bearing inside the turbo to allow the shaft of the turbo to spin on a ceramic ball bearing, in comparison to the standard Insignia one, which uses a journal bearing. The benefit of the ceramic ball bearing turbo is that it can take a great deal more abuse, but the biggest benefit is because it has less rolling resistance, it actually spools up much faster. But there are a few other subtle changes as well. The VNT is much different on the GTD series than it is on the GTB series. Now the GTB is a reasonably decent setup. I'll just try and sort of go through it with you so that you can see. So the actual turbine gases from the exhaust manifold come in and they are pointed towards the turbine by the VNT system. Now this one is totally fucked, so I can't actually move it, but you can just about see the blades in there, and they point the exhaust gases towards the turbine. This is the turbine here. Okay, that provides all of the momentum for the compressor wheel so that we can get our boost. Now the difference between the two is quite clear. You look at the two of them right up close to each other. Let me try and see if I can get you to see that. And you can see that the actual GTD series on the right hand side has actually got two more blades than the standard Insignia one. Now the standard Insignia one is also smaller. So this is a 15, whereas this is obviously a 17. So this has got a larger turbine, which means it'll be able to drive the compressor better. And obviously this one is quite small really, but it's okay for a standard turbo. So what we've got on the hot side, this is the turbine housing. This is for the GTD series, but it's actually quite similar to the Insignia version, except instead of using V-bands, it uses a bolt-on flange. So the exhaust gases from the manifold come into here, they curl around here like this, and then they're forced onto the actual blades, which then focus, you can just about see the blades there, focus all of the exhaust gases and all that energy onto the actual turbine itself, which is what drives the turbine. You can see it's a very, very similar setup to the Insignia version. This one here will take more heat though, and the reason it will take more heat, or part of the reason it will take more heat, is because it has this really thick cover plate that goes on over the top of the VNT, okay, whereas this one doesn't. This one it does have a plate there, but it's not as thick as this one, so obviously a great deal more of the heat is actually transferred onto the blades, which can potentially damage them. This turbo will take exhaust temperatures of about 800 degrees, whereas this one will take 900. So 100 degrees may not seem that much different, but trust me, it really is. Okay, now the other thing that we've got with the GTD series is actually the way that the exhaust gases, once they've been through the turbine, how they actually vent. Okay, so in the Insignia turbo, very similarly, they do vent through a pipe, which then obviously collects to the downpipe, very similar to this. But if you actually have a look on the turbine housing, you can see it goes straight into there. This would be where it bolts to the exhaust pipe. The actual pipe here is 10 millimeters bigger on the GTD series than it is on the standard Insignia. So that's going to potentially give us much better exhaust flow. It's also going to drop the temperatures down, because anything that strangles the exhaust gases from getting out of the turbo is obviously going to build up heat. Okay, so 10 millimeters is quite a considerable size difference. So this is 10 millimeters bigger than the standard insignia. Now turning that over, this is actually the flange which I'm going to replace, but this flange actually bolts to the exhaust manifold. This is about 8mm bigger than the standard flange for the insignia. Now I toyed with the idea of building myself a log manifold for the insignia, and I just thought, no, do you know what I mean? I want to actually keep it so it's not a massive, huge build like I used to do in the old days. I still want something which is relatively easy, relatively bolt-on. So I've gone with using the original insignia manifold. The original insignia manifold isn't amazing at flowing gases, simply because the way that all 4 of the exhaust ports all focus into one, as is, instead of sort of, you know, they all come down one end, which is, it's not a great design, but it's functional. So what I'm going to have to do is I'm going to have to weld a V-band onto the exhaust manifold of the insignia, and then I'm going to cut this off here and put another V-band on there, so that'll bolt straight onto the insignia manifold. I've already got a DPF delete pipe, but what I'm going to do is I'm actually going to weld this, so I can just get it on there, weld that V-band connector onto the GTD turbine housing, and then I'm going to have to weld obviously the other end onto that downpipe. So, you know, it is coming along. We're waiting on a few parts, waiting on another V-band connector. The other issue that I've obviously got with this turbo, as you can see, I've fabricated a VNT actuator. This will sit very similarly to the standard insignia turbo, with the actuator in a very similar spot. You look down inside the actual, look at the compressor. Now look at the compressor in the standard insignia, which you can't see all that well. It's a pretty small affair, and it's only got, I think, 6 blades off the top of my head, whereas this one's got many more. So I haven't actually counted the amount of blades. It's got 1, 2, 3, 4, 5, 6, 7, 8 or 9 blades. So this one will spool faster and flow better. This has also got a billet compressor wheel on it, which is made out of billet aluminium. So not only is it stronger, it's much lighter, and obviously it's also 7mm larger than the standard one as well. Now the next challenge that I have is obviously the outlet for the compressor. So this turbo is going to sit like that. So those of you who know the Insignia turbo can see straight away that the outlet for the compressed air is in the wrong position. So what I'm going to have to do is I'm going to have to fabricate some kind of a pipe setup which allows us to feed this obviously into our intercooler. That's maybe a bit of a challenge because the space is a bit restricted there, but I'm hoping that probably in about 2 weeks' time we should be at that stage. So speak to you very soon.